Okay, let's look at an example using the equilibrium expression. So I'm going to write out the problem and then we'll write the formula and go from there. So nitrogen gas and oxygen gas are in equilibrium with nitrogen monoxide. At equilibrium, the mixture contains 0.040 molar nitrogen and 0.010 molar oxygen. What is the concentration of nitrogen monoxide if the Kc is 1.0 times 10 to the negative 30th? Okay, so from this word problem, we need to be able to write the equation, balance the equation, write the equilibrium expression, and solve for nitrogen monoxide, solve for the concentration of nitrogen monoxide. So whenever I am faced with a problem like this, the first thing that I do is write out the steps that I'm going to take and the plan, the path that I'm going to take to solve these problems. You are never going to be graded on the way that you solve the problem. You will need to show your work on exams, but if you choose to take a different path or plan than I do in these examples, that is totally fine. I just recommend doing it this way so you're not just calculating values aimlessly. So again, you don't have to solve them this way, but this is what I strongly recommend. Okay. So the first thing that we're going to do is we're going to write the equation. Then we're going to balance the equation. Sometimes the equation is already balanced. You can't ever assume that, so we'll just check. Then we're going to write the equilibrium expression. And then we're going to solve for the concentration of nitrogen monoxide. So that's what I'm going to do. So step one, let's write the equation. So it says I have nitrogen gas and oxygen gas are in equilibrium with nitrogen monoxide. So to me, what I would do is I would say N2 gas plus O2 gas is in equilibrium with, don't forget this double-sided arrow, with nitrogen monoxide, which is a gas. I would tell you that. I wouldn't expect you to know that. Nitrogen monoxide is a gas. So this is the equation as it is written. We always need to make sure that the equation is balanced. This equation is not balanced because I have 2 nitrogen on this side, 1 nitrogen on this side, 2 oxygen, 1 oxygen. So I can easily balance this equation just by giving nitrogen monoxide a coefficient of 2. So I'm just going to write that again. Nitrogen gas plus oxygen gas is in equilibrium with 2 moles of nitrogen monoxide gas. Now I'm going to write the equilibrium expression. So the equilibrium expression, remember what that is. The equilibrium expression is the Kc equals the concentration of the products over the concentration of the reactants. Now remember the rules. Coefficients become exponents, and pure substances are excluded. So let's write the equilibrium expression, making sure to follow those rules. So I'm going to say Kc equals the concentration of the products, which is NO, nitrogen monoxide, squared over the concentration of the reactants, which is nitrogen times oxygen. Now, it is very important that we made sure the equation was balanced. If we didn't make sure the equation was balanced, then we would not have balanced it by using this 2 coefficient here, and we would not have known to square this term in our equilibrium expression. Do not forget to make sure that your equations are balanced. Do not forget that the coefficient of the term becomes the exponent. So now we've written the equilibrium expression. Now the only thing we have left to do is solve for the concentration of nitrogen monoxide. So nitrogen monoxide is the only thing I don't know in this equilibrium expression. I'm told in the problem the Kc is 1.0 times 10 to the negative 30th. Again, remember there's no unit for the Kc. And I am told that at equilibrium, the mixture contains 0.040 molar nitrogen and 0.010 molar oxygen. So now I can solve for nitrogen monoxide. So let's do that. So I'm going to say Kc 1.0 times 10 to the negative 30th. And you are going to find that for a lot of these problems, the position of equilibrium, which is what the Kc tells us, usually is a really big number or a really small number. So it's not uncommon to see a really big exponent like this. Okay, so Kc equals the concentration of nitrogen monoxide, which is what I'm solving for, squared over the concentration of nitrogen, 0.040, times the concentration of oxygen, 0.010, and now we're just going to solve for nitrogen monoxide. So I'm going to say 0.040 times 0.010. I'm going to take that, I'm going to multiply this side to get rid of these on the bottom. So I'm going to say 0.040 times 0.010 is 4 times 10 to the negative 4th. I'm just going to write each step out for this first problem. So I'm just going to write this again. 1.0 times 10 to the negative 30th equals the concentration of nitrogen monoxide squared over 4 times 10 to the negative 4th. So now I'm going to multiply both sides by 4 times 10 to the negative 4th. So that times 1.0 times 10 to the negative 30th. Make sure you're always using parentheses when you are multiplying things with exponents, because it will just raise everything to that exponent, not just the term that you want it to. So now I'm going to write this out again. So now this 4 times 10 to the negative 4th times 1 times 10 to the negative 30th equals 4. I'm going to just write 0.0 in all of these just to maintain correct significant figures. 4.0 times 10 to the negative 34th equals the concentration of nitrogen monoxide squared. Well, I just want the concentration of nitrogen monoxide, not nitrogen monoxide squared. So I'm going to take the square root of both sides, and I'm going to get 2.0 times 10 to the negative 17th. It's 2.0, and its molarity The reason it's 2.0 is because we always have to pay attention to the correct number of significant figures. This number has 2 significant figures, this number has 2 significant figures, and the KC has 2 significant figures. The KC, the number of significant figures in the KC, is not applied because it is a ratio. It's an exact number. It's not a measured number. So we would just be going off the significant figures here of the 2 concentrations, which are both 2. So if you put 2 times 10 to the negative 17th molarity on an exam, you would lose a point because it would not have the correct number of significant figures. So this is the concentration of nitrogen monoxide at equilibrium. Again, it's important to keep in mind that all of this is happening at equilibrium. This Kc equals concentrations of products over reactants is at equilibrium. So it's important to see that in the problem because not all of the problems will be this way. So that's an important key when you're reading the word problem to let you know what type of problem this is. So this is an equilibrium expression example, similar to what I would expect you to see on homeworks and exams.